let's look at number 4. So this is where it starts to really get interesting. Remember, step 1 is to choose a variable to be eliminated and eliminate it. So let's say we just went ahead and added these two equations together, because that's what we've been doing this whole time, right? Just adding them together. So if I add these together, I get plus 2x minus 2y equals 8. Notice that neither x nor y went away. Neither of them were eliminated or disappeared. So clearly, just adding these together and not doing anything else isn't going to work. So that's where we really need to start looking at this other piece, which says that we need to do something to obtain variable terms that have the same number and opposite signs. Okay? So we could try to make these two values the same, these two coefficients, negative 3 and 5, or we could try to make these two numbers the same. Okay? So you can pick either one you want. What I'm going to do is I'm going to try to make the y coefficients the same number and opposite signs. Why am I picking the y and not the x? Well, if I want 2y and negative 4y to have the same number and opposite signs, all I'd have to do is multiply this by 2. That would give me 4y in one equation and negative 4y in the other equation. And then when I added them together, that would give me 0y. Okay? So because I only have to multiply one equation by a number and not both equations, that's what I'm going to choose. Is that the only way to do it? No. To me, it's the fastest. So I mentioned that you have to multiply the whole equation by 2. And the reason for that, right, is that I can't just change one term of the equation. I have to change the whole equation, or else the equation isn't true anymore. Okay? So we're going to multiply this whole equation by 2. So negative 3x times 2 becomes negative 6x. 2y times 2 is 4y. Negative 10 times 2 is negative 20. So that's my new equation. Then I can just bring down the other equation. And now let's see what happens when we add these. Negative 6x plus 5x is negative 1x. Then 0y, these cancel out, and that gives me negative 2. Okay, so all of this was step 1. Okay, so again, notice that I have to do this extra step. I had to multiply one of my equations by a number in order to force one of my variables to be eliminated. So let's go ahead and do step 2. We can simply divide by negative 1 on both sides, and we find out that x is equal to 2. So that is my step 2. Okay, so from here, everything proceeds just as it has. Everything else is the same that we've been doing before. Okay, so something to think about if this step confuses you, how to obtain two terms that have the same coefficient and opposite signs, you can practice just that step. Okay, you don't have to do the whole problem every single time. So again, if you have trouble figuring out why do we multiply one of those equations by 2, right? Find a bunch of examples. Do that ungraded extra practice in Brightspace, and just do that over and over and over again until you're comfortable with doing that first part, the eliminating one variable. Okay, so let's move on to step 3. Right, step 3, I can pick either equation, does not matter which one. I'll just use the first equation because, why not? So I have negative 3x plus 2y equals negative 10. Okay, we found out that x is equal to 2. So we'll put 2 in there. So we have negative 6 plus 2y equals negative 10. So we will add 6 to both sides. We get 2y is equal to negative 4. Kind of out of room here, but I'll divide both sides by 2. And we get y equals negative 2. Okay, so if we are correct, right, and we don't know yet because we haven't checked our work, but if this is correct, we should get x is positive 2 and y equals negative 2. Okay, but again, it's always a good idea to do that last step there. Okay, so remember in step 3, I use this equation. Another thing to notice is I always go back to the original equation. I don't use this equation right here because I'm human and I might have made a mistake when I did my multiplication, right? So if I go back to my original equations, then I'm not recycling any mistakes that I might have made. Okay, so again, we've already used that equation. We must use the other equation, which is 5x minus 4y equals 18 if we want to check our work. Okay, so we said that x is equal to 2. We said that y is equal to negative 2. So we have 5 times 2 minus 4 times negative 2 is 18. So we have 10 plus 8 is 18, or 18 is equal to 18. Okay, so we have checked our work and it is correct. Awesome. Okay, let's look at this next example. So we have x plus 2y equals negative 2, and we have negative 2x plus 8y equals 10. So hopefully you can see if we simply added these without doing anything else, we get negative 1x plus 10y equals 8. So doing that does not eliminate either x or y. So that means that we have to do an extra step. So we could eliminate either x or y, but notice if I have x and negative 2x and I want to add them and I want to get 0x, all I would have to do is put a 2 here, because 2x plus negative 2x is equal to 0x. Now remember, you can't just change one term of an equation, you have to change the whole equation. So what we would have to do is not just multiply x by 2, we'd have to multiply the entire equation by 2. So let's see what that looks like. 2 times x is 2x, 2y times 2 is 4y, negative 2 times 2 is negative 4. Let's bring down the other equation and then add them together. So 2x plus negative 2x is 0x plus 12y equals 6. Okay, and then we can divide both sides by 12 and we get y equals 1/2. Okay, so again, remember, all of this is only step 1. Well, step 1 and step 2. This is step 1. This is step 2 of our process. Okay, if we're filling things in, right, we only have half of our answer. We have our y value. Okay, so we still have to do step 3 and we still have to do step 4. Okay, so step 3 is that we have to use either equation to find our x value. So let's use this equation here. X plus 2y equals negative 2. And again, remember, I always go back to my original equation. I always go back up here to the top. Okay, so if x is equal to y is equal to 1/2, we'll put that there. Okay, so x plus 2 times 1/2, half of 2 is 1. So x plus 1 is negative 2. We can subtract 1 from both sides, and we get x equals negative 3. Okay, so we don't want to walk away from this problem, remember, until we've checked our work. Okay, so remember, in step 3, we used this equation right here. If I want to check my work, I have to use the equation I didn't use in step 3. So that's negative 2x plus 8y equals 10. So as you can see, I'm out of room, so I'm going to check it on this next page here. Okay, so negative 2x plus 8y equals 10, and again we have x is negative 3, and y is positive 1/2. So x is negative 3, y is positive 1/2. Okay, so negative 2 times negative 3 is positive 6, half of 8 is 4. So we get 6 plus 4 is equal to 10, or 10 equals 10. And again, that is step 4. So since we have a mathematically true statement in step 4, that means that our solutions for x and y are correct. So we can stop here and we can say that the solution to our system is negative 3, 1/2, or x equals negative 3 and y equals positive 1/2. Let's do another problem. So once again, we have to pick one variable that is going to be eliminated. hopefully you can see that if all I did was just to add these two equations together, neither x nor y would cancel out. So that means that we have to do an extra step in order to make two things cancel out. I'm going to choose my x variable because they already have opposite signs. So right now I'm going to take negative 6x and 2x, and remember I want to add them together and make them 0. Okay, so if I multiply this by 3, that would give me negative 6x plus 6x, and of course they would cancel out and give me 0 or 0x. Okay, so that means that this whole second equation is going to need to be multiplied by 3. So we have 3 times 2x is 6x, 3 times 3y is 9y, 3 times 2 is 6. Then I'm going to bring the other equation that I did not modify, bring that down, write that underneath, and then I will add these together, and that gives me 14y equals 28. Okay, so again, all of this is step 1. So now I'm on to step 2, which is to find the value of, in this case, y. If I divide both sides by 14, I find out that y is equal to 2. So now I can move on to step 3. I can choose either equation, but remember I always go back to the original equations, not the ones that have been multiplied. Okay, so for step 3, I'll just go ahead and use the first equation. So that's negative 6x plus 5y equals 22. And we said that y was equal to 2. So I have negative 6x plus 5 times 2 is 22, or negative 6x plus 10 is 22. We subtract 10 from both sides. We get negative 6x equals 12. We divide both sides by negative 6, and we get x is equal to negative 2. Okay, so right now, it looks like x is negative 2, and it looks like y is positive 2. However, remember, we're not really done until we check our work. So step 4 says we have to use the equation we did not use in step 3. Again, in step 3, we use that equation there, the first equation. So in step 4, I must use 2x plus 3y equals 2. Okay, so we said x was negative 2. We said that y was positive 2. So let's see if this checks out. Negative 4 plus 6 is 2. 2 equals 2. Sure enough, it checks out. So we can be confident that our solution, negative 2, 2, is correct. Okay, let's do another problem. So once again, you can see that if all I try to do is just add these two equations together, neither variable will be successfully eliminated. So what does that mean? That means we have to do an extra step or two. Now this one's a little bit tricky because we have all of our x terms have the same sign and all of our y terms have the same sign. Okay, so you can pick either one. I'm going to decide that I want to eliminate my x's. Okay, so how would this work? Well, how do I make 3 into the same number? So this is very similar if you remember the process of finding a common denominator. So for example, let's say I had to add 1/3 and 1/2, right? Well, remember you can't add fractions with different denominators, so you'd have to multiply that by 2 over 2, and you'd have to multiply that by 3 over 3, and you get 2 6 plus 3 6 equals 5 6. Okay, so in the same way, I'm going to do a very similar thing here. I'm going to multiply this by 2, and I'm going to multiply this by 3. So let's see what happens when we do that. So that would give me 6x plus 6x. Well, the problem here, right, is 6 plus 6 is 12x. It is not 0x. So there's one other thing I'd have to do here, and that is simply that one of these has to become negative and the other one has to become positive, right? They have to have the same number, which is 6, but they also have to have opposite signs. Okay, and it really doesn't matter, right? It doesn't matter where you put the negative sign, so I'm just going to pick somewhere. So I'll pick this one. Okay, so I'll make this one negative, so now I have negative 6x plus 6x, and that gives me 0x. So what does this mean? Well, that means that I have to multiply this whole first equation by negative 2, and I also have to multiply this whole second equation by positive 3. Okay, so let's take a minute and do that and see what happens. So 3x times negative 2 is negative 6x. 6y times negative 2 is negative 12y. Negative 9 times negative 2 is positive 18. Okay, so that's my first equation. 2x times 3 is positive 6x. 9 times 3 is 27, so we have plus 27y. And, oh my goodness, negative 26 times 3 is 78. Negative 78. Okay, so now let's see what happens when we add these together. Okay, just as we planned, our x's cancel out. Okay, then we have a negative 12 plus 27. That gives us a positive 15y here. And then we have 18 minus 78. That's going to give us negative 60. Okay, so again, remember all of this is still just step 1, eliminating one variable. Okay, so now we can divide both sides by 15, and we get y equals negative 4. That's our step 2. Okay, so if we're correct, then we're headed towards one solution where y equals negative 4. So let's look at step 3. Remember, in step 3 you can use either equation. Again, I always go back to my original equations before I multiplied them by anything else. So for no particular reason, I'm just going to use the first equation. I don't really have a preference either way. So I'm going to put negative 4 in place of y. So we have 3x minus 6 times negative 4 is negative 24 equals negative 9. And we need to add 24 to both sides. And we get 3x equals 15. Then we would have to divide both sides by 3, and we find out that x equals 5. Okay, but again, we've done a lot of work here, guys, and you know, the probability that I made a mistake somewhere is pretty high. So I'm going to go back and I'm going to do this fourth step, which is to check my work. Now, as I mentioned before, you have to use the equation you didn't use in step 3. So I used already this 3x one, so I have to use the other one, which is 2x plus 9y equals negative 26. So that's going to give me 2 times 5 plus 9 times negative 4 equals negative 26. So 10 minus 36 is negative 26. Well, 10 minus 36 is in fact negative 26. So we get negative 26 equals negative 26, and sure enough, that checks out. Okay, let's do another problem. So we have 4x minus 6y equals 8, and we have 6x minus 9y equals 15. So once again, right, if I just add this and don't do anything else, you can see that you get 10x minus 15y equals 23. So simply adding these two equations together is not going to achieve our aim, which is to eliminate one variable. So you can pick x or y. I'm just going to pick x because, you know, why not? So remember, our ultimate goal is that these add up to 0. Okay? So if you want to think about fractions, if I had 1/4 plus 1/6, okay, you could multiply this by 3, and you could multiply this by 2, and you get 3/12 plus 2/12, and you get 5/12, because 12 is your LCD. Now, some students really struggle with finding the LCD, the smallest number that's divisible by both things. So a shortcut, okay, is to literally just swap the numbers. Okay, so in other words, the 4 is missing a 6, and the 6 is missing a 4. So 6 times 4 is 24x. 4 times 6 is 24x. Now, as you can see, right, 24 plus 24 is 48. So there's still one thing we have left to do, and that's to make one of these two things negative. Okay, and remember, it doesn't matter which one you pick. It does not matter. So just because I did the opposite last time, I'll make the second number negative this time. So 6 times 4x is 24x. Negative 4 times 6 would be negative 24x. And sure enough, 24 minus 24, of course, is 0. Okay? So if that's going to work, that means that the first equation is going to get multiplied by positive 6. And the second equation is going to get multiplied by negative 4. Okay? I want to encourage you guys to remember you could also have multiplied the first equation by 3 and the second equation by negative 2. That is valid. Okay? All right, so let's go ahead and do this. So 4x times 6 is 24x. Negative 6y times 6 is negative 36y. We get equals 48. This gives us negative 24x plus 36y equals negative 60. Okay, this looks interesting. So we get 0x plus 0y equals negative 12. 0x plus 0y is just 0. So we have 0 equals negative 12. Okay, so remember, this is step 1. Okay, this is step 2. We're only in step 2 right now. Okay, so what did we say we should do when we have a mathematically false statement at the end of step 2? Well, remember, this means that there are no values of x or y that is ever going to make this statement true. So that means there is no solution. It's really nice because guess what? We're done. We don't have to do step 3 or 4. We can't do step 3 or 4. Okay? Again, if you really want to check your work, the only thing you could really do is go back and, go over each step and verify your arithmetic and verify your algebra. So that's the end of this problem. Let's look at this last example. We have x minus 2y equals 3, and we have 3x minus 6y equals 9. So again, if we were to simply add these down, we get 4x minus 8y is equal to 12, which eliminates neither x nor y. So we have to do something to this equation in order to make the variables have the same coefficient and opposite signs. You can pick x or y. I'm going to choose x. So again, right now if I add x and 3x, I clearly don't get 0x. So I'd have to put a 3 here, and then I would have to make it negative, so that negative 3x plus 3x equals 0x. So that means this whole equation needs to get multiplied by, negative 3. Okay, when we do that, we get negative 3x plus 6y equals negative 9. So let's bring the other equation down below that, and then we will add them together. This gives me 0x plus 0y equals 0, or 0 equals 0. This is a mathematically true statement, and remember, whenever that happens in step 2, because this is step 2, this is step 1. So when we get a mathematically true statement that doesn't contain any variables, right, 0 equals 0, there's no x or y left, that means there are infinite solutions, and that would be our final answer.